First one, isolated intersection analysis. So what it is, and you guys have this as a part of your system, so I don't need to go into a lot of detail, but when we think about it, it's measuring the average peak hour delay for vehicles at an intersection. And the LOS is really based on how long a vehicle is waiting at the intersection. And the Highway Capacity Manual prescribes level of service grades to different vehicle delay thresholds. Again, it focuses on improvements that alleviate congestion during the hour of measurement. So if you have a PM peak hour, or if you have an AM peak hour, commute hour condition, it's not necessarily being measured if you're looking just at the PM peak hour. In terms of your synchro system right now, one thing that we could look at is just extending how far each of the isolated intersections measure the delay. Something that I haven't looked at is, because we have DEA leading this work, is for the intersections, it depends on how long they've allowed that queue to be measured. To the extent for your commute that you talked about, there's a very long queue length that you're waiting in. So that is actually potentially a very simple fix the city could look to do, is to extend kind of the length of measurement for those queues for isolated intersections. It would potentially show higher overall delays, could potentially show more existing deficiencies, but to Councilmember Odell's comment, potentially it's a bit more accurate.
Yeah.
So to answer your question, yes, there's the way that we use it is a software called Synchro. And so that software, what it does is, first of all, we go into the software, and actually I feel like I had, here's an image, I'm just going back to this slide. That's actually a screenshot from Synchro, and there's a lot more detailed sheets behind there that you can get into. But what Synchro does is it takes first the person that's programming it and building your Synchro network. First you try to replicate real world conditions. So turn pocket, the number of lanes on a roadway, the number of turn pockets, the length of those turn pockets. We also go into the traffic control parameters. So if there's for example, a traffic signal, we'll get the signal timing plans from the city and make sure that that signal is reflecting what real world conditions are. But what then the software does is we also program in the traffic volumes, and we can program them in by 15-minute or by hour, and sometimes apply that peak hour factor that Andrew related to. We'll also put in the volumes of pedestrians and cyclists, and make sure that we get in even those walking intervals in the software. And what it does is it actually calculates for all the vehicles that are in there, it actually calculates the average amount of time that they're waiting. Doing that by hand, as you can imagine, if you were to think about it, a signal, you could certainly go out and watch a vehicle go through and measure how long it's taking them. But to do that for enough vehicles, to do it in a statistically valid format, is data prohibitive. So that's why the profession tends to use these computer softwares. So, if I may, I want to make sure I'm understanding the concern. When I build, and it's been a few years since I've built some Synchro models, but when I would go about that effort, one of the things are, you don't build Synchro models in cities you're not going to, and you're not observing field conditions. So yes, we're not going out and observing field conditions at every of your 44 intersections and every approach. But I would go out to the primary intersections where we have questions about their operations, and I'd go out there and observe. And I'd say, is this looking like my Synchro model? I can watch from the back of the queue and see how long it's taking a vehicle to progress, how many cycle failures we're having, and making sure that the results that we're getting out of our Synchro model are reflecting real world conditions. So if your concern is, have we put enough time in the field to ensure that the results we're getting out of this computer simulation are valid, I think that's a very good question, and I think that's time that the consultant team could put into doing that, to the extent that it hasn't already happened. And I'll let others speak to that. However, in terms of is this state of the practice? Is this what other communities are doing? The answer is absolutely yes. Second piece was that the council generally favored an intersection-only concurrency policy. And I know that while there is discussion about moving into the future, at some future date, incorporating travel time or some of those other more innovative metrics, I think in the interest of time, the previous council kind of favored, let's go with an intersection-based concurrency policy and do away with the segment-level measures. While that's a fairly simplistic approach, it's very consistent with what a lot of other cities do. And intersection-based policy really does focus on the driver experience.
There are a couple of challenges, though, with both the Syncro and the SYDRA. If traffic is at a standstill, it doesn't know how to manage that. So that's a limitation of the model. It just they don't know how to handle standstill.
So one thing is the congestion itself is not really being measured today, right? We don't really have people on the ground saying, okay, this is how many cars are getting through, or this is how long the queue is, like on Sahalee, for example.
So on the congestion itself is not directly measured because it's a time-based, distance-based, volume-based, which we can't have enough people out there with their stopwatches, but then again, that incorporates more human error.
Yeah.
Is what you presented to council on those one-on-ones, or what staff presented, and then what is in our deck here, which is the two limitations of Syncro, which is giving us our what's going on right now. And so I'm going to read them because they were up there before, but can't predict operational impacts at an intersection if delays are caused by a downstream choke point. Does not know how to handle standstill traffic conditions, so it assumes it doesn't occur. But it does occur. It
Absolutely.
does. And so how are we making up for the fact that we actually do have standstill traffic in Sammamish?
Absolutely. I think everyone in this room would absolutely concur with that. And while these guys might not have been standing there, let me just say I often come to Sammamish for 9 a.m. meetings, and I'm coming up from 202 and up. So I have observed those queues, and so I'm painfully aware of what folks are dealing with every day. And I say, thank goodness I'm coming into Sammamish and not leaving. What I would say is that there's a lot of weight hanging on this concurrency policy right now, and a lot more weight than one concurrency policy can bear. The TMP, I strongly think that yes, standing queues are a huge issue here. We need to model them. We need to understand them. Now, is that something that is appropriate to put in place for something that's going to be done routinely for development review? That's not typically where it's done, and I would say Sammamish has a number of seriously congested corridors. 228 Sahalee Way is one of them. Issaquah Pine Lake Road is one of them. Issaquah Fall City Road. There's a number. I could keep going. 244th is another one. These are ones where, as a part of the TMP, we are going to want to look at it from a variety of ways, but probably do some simulation modeling. That's the only sort of assessment that can really properly address what are these queuing issues, and then to really come up with what are those needed solutions and how do we program them into our project. So, what I'd say is I'm absolutely with you, but just in terms of the narrow lens of concurrency really isn't the place to address that. That's really.
So I hear what you're saying, but I'm still struggling with that queue, even if we can address it in the TMP, because we are adopting what you're telling us is actually transpiring on the roads right now in the transportation element of the comp plan, and you're telling me there's a 12-second delay at 37th and Sahalee.
Well, and that's where I think that
to 8, but not at 8:45 when we have the peak spreading happening.
And what I would say is that, for that sort of situation, maybe that's, that other solution that staff had produced earlier this year, which was looking at, segment. So I talked with some of the experts in our office, I've talked to poor Josh about this. Really, probably, at this point, isolated intersection analysis isn't really able to address that issue. First one, isolated intersection analysis. So what it is, and you guys have this as a part of your system, so I don't need to go into a lot of detail, but when we think about it, it's measuring the average peak hour delay for vehicles at an intersection. Again, it focuses on improvements that alleviate congestion during the hour of measurement. So I talked with some of the experts in our office. I've talked to poor Josh about this. Really, probably at this point, isolated intersection analysis isn't really able to address that issue.